Okay, 6.2, we're talking about sum difference and double angle identities. So I have the sum identities, and I'm going to add a few here to them, and then the double angle identities. These all, again, you get on your formula sheet. You just have to know how to use them, okay? So we don't have to memorize these. For the sine A plus B, do you guys see those ones? There's also negative versions of those. So the negative version I didn't put on there. So our second sine one is going to be a negative version of it. And, okay. And so it looks like this, so we'll add this to our sheet. If you have a negative in between, then it looks like sine A cos B subtract cos A sine B. Okay, so we'll add that one. You can put it under your sine A plus B, or you can put it beside it. And cos A plus B also has another one. If it's cos A minus B. And it follows the same as the positive version, except it just has a positive in between if it's the negative one. Okay, so those are 2 extra for that, and we still have the tan A plus B is equal to tan A plus B over 1 minus tan A tan B. Okay, so these will make more sense once we start getting into using them. And then the double angle identities, you have if sine 2A is equal to 2 sine A cos A, and then cos 2A is equal to cos squared A minus sine squared A. So this cos 2A one, it has 3 options. So I gave you one. There's another one, okay, or another 2, I guess. So cos 2A, this is the one I gave you. It could also be this is another option, or it could also be 1 minus 2 sine squared A. Okay, so cos 2A, it has 3 options. Depending on what you want to do, that's which one you choose. Okay, so if you're trying to, your goal is trying to get sines or something like that, then you'd probably use the last one. If your goal is just to have coses, then you'd probably use the middle one. Okay, and then we still have a tan 2A one, is 2 tan A over 1 minus tan squared A. Okay, so those are the additions that we're making to our sum identities and our double angle identities. Okay, so looking at example 1, it says write each expression as a single trig function. So we should get it down to just one simple answer. Okay, so we have sine 48 cos 17 subtract cos 48 sine 17. Okay, so now looking at those sum identities or double angle identities, let's first, are these sum ones or double ones that we're talking about right now? Okay, do we see any 2's in there? Okay, so it's not double, it's sum ones, right? So look at your sum identity ones. Does this look like any of the ones that we kind of wrote out with the A's and the B's? Which one? Like the sine one? Okay, so it looks like sine A minus, A minus B. Okay, because if you follow that one, sine A minus B goes sine A cos B minus cos A sine B. So that seems to follow the pattern. So all you have to do is, since we've identified it's the sine A minus B, what's our A in this situation? 48. Okay, so you'll say sine 48. And what's our B then? 17. So you'll go sine 48 minus 17 and you get sine 31. And that would be our answer. Mm-hmm. Okay, so that wasn't too bad. Once you identify which one you use, right, then it's not too bad. Okay, so the next one, so B says we have cos squared pi over 3 minus sine squared pi over 3. Okay, so which one of these does this look like? Any of the identities that we wrote out? Which? It looks like cos 2a, because cos 2a is cos squared minus sine squared, right? And this is cos squared whatever minus sine squared whatever. So this is actually cos 2, and then instead of a, what's our a in this situation? Pi over 3. So it's cos 2 times pi is 2 pi over 3. And that would be our answer. There's no other side. Okay, so example 2 says determine an identity for cos 2a that contains only the cosine ratio. Okay, so I gave you the other ones. So where in the double cos 2a, which one is it that only has cosine in it? 2 cos squared a minus 1. Right. Okay, so that's what they're asking you. But if you actually wanted to solve that out, if you didn't know that, okay, we could say, okay, we were given that first initial one, which was cos squared a minus sine squared a. Okay, so say we wanted to get rid of this sine. And do you guys remember that one identity that was like sine squared plus cos squared equals 1? It was called the Pythagorean identity. We had it on 6.1. Okay, so remember we can manipulate that. We can make it cos squared by just subtracting away the sine squared. So then it would look like cos squared is equal to 1 minus sine squared. Okay, and vice versa, you can also go, if you had sine squared plus cos squared equals 1, you could subtract away the cos squared. And then you would have sine squared is equal to 1 minus cos squared. Okay, so in this situation, we're going to use this to replace our sine squared, because we're just trying to get coses. Okay, so I would still have this cos squared here because I did nothing with that, and I'm replacing this sine squared with 1 minus cos squared because it equals the same thing. And I should put a in there just because we have a. Okay, so all I did was replace my sine squared with what it could equal. So now if we multiply in, we're multiplying in a negative, so we get cos squared a minus 1 plus cos squared a. And so you got 2 cos squareds, and you have a minus 1. And so you'll notice that's what we said it would equal. Okay, so that's where they get those other parts of the formula from. Okay, example 3, we have 1 minus cos 2x over sine 2x. And it says, what are some non-permissible values? So what does sine 2x equal, actually? Do we have that anywhere in our double angle identities? What's up? Oh, it's probably supposed to be non-permissible. I thought it was equal to 2 sine... Oh yeah, a. I had x's, sorry. Whoops. There we go. So 2 sine A, so basically we got to look and see where sine is going to equal 0 and cos equals 0, because we don't want that bottom to equal 0. So we don't want sine A to equal 0, and we don't want cos A to equal 0. And technically I probably shouldn't be using A's, I should be using X's, because that's what's in the question, but it doesn't matter. Yeah, so this one's pi, which is 90, and this one is, the cos one should be half pi. Oh no, this one's 90, sorry, this one's 180. Okay, so then you could just write that as 90, 180, dot, 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 or you could write it as half a pi, and then pi n, dot, 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 keep going. Okay, so that's the non-permissible value. And then if we want to simplify the expression to one of the 3 primary trig ratios, it means we're going to make it as easy as we possibly can. Okay, so that means when we just break everything down until it's as simple as it could possibly be. Can't cross the 2's out. Because this sine 2x goes under the 1 also. You know, so he would have to be a 2 also. Okay, can we change this guy? Because we don't have a cos, we got a sine down here. Maybe we can change that cos 2x into something that's sine, so that we get just everything to be sine. Or what else could it be without getting rid of, is there one with just sines? Is there this one? 1 minus 2 sine squared. Okay. Okay, so all I did was replace the cos 2x with that, okay, with what's in the bracket. And while we're doing that, maybe we want to change the bottom too. So we had said that sine 2x could be what? Here we had, yeah, so 2 sine A cos A. Okay. So now, I'm just going to times this negative in to both pieces. So we have 1 minus 1 plus 2 sine squared A. All over 2 sine A cos A. Okay, so 1 minus 1 is 0, so those are just gone, right? So then you end up with 2 sine squared A, and you have a 2 sine A cos A here. Yeah, we can cross off because we have a 2 sine squared, so that's 2 of them, and we have a 2 sine here, right? So if we cross 1 off here, then we're just left with a sine A on the top, a sine squared A, a sine A over a cos A. And what is a sine A over a cos A? A tan A. Okay, so example 4 is our last example. It says determine the exact value of each expression. So remember, where do we get numbers when we're talking exact values? Off of what? Unit circle or special triangles, right? We made the unit circle out of special triangles, so we use the unit circle, but you could use special triangles as well, right? Okay, so we want exact value of sine pi over 12. Okay, whenever I see sine pi over 12, I'm like, I don't know what angle that is. I have a hard time seeing things in radians and understanding what angle that would be. So a lot of times I just switch it in my head, because we remember that we can go 180 times pi to switch anything to a degree, right? So you can cross off pi's, and if you go 180 divided by 12, you end up with 15 degrees. Okay, so 1/12 is 15 degrees. Okay, and once it's like that, I don't know if you guys care if it's in radians or not. You can look at your unit circle, but I always think 15 degrees is easier to wrap around in my head than pi over 12. Okay, so can I think of the special triangles angles? They're 30, 60, 90, 45, 45, 90. Any of those, if we added and subtracted them together, get us to 15 degrees. Okay, so sine what? Subtract what? Or sine what plus what would give us 15? Using only the 30, 60, or 45. What's that? Yeah, so 45 minus 30 would give us 15. Okay, so that's where we go with this because, oh, sorry, 30. This is what we do because we don't have 15 degrees on our unit circle, right? So we have 45s and 30s, so that's why we use these sum identities. Okay, so now this is a sum identity, 45 minus 30. We know we'd be using the sign a minus b1 then. So the sign a minus b1 goes sine a minus b is equal to sine a. So in this case, our sine a is 45. Our cos, and then b is 30. Subtract cos a, which a is 45, sine b, which is 30. Okay, so all I did was use my sum identity, and I plugged in the 45s and 30s. Okay. So now, since we know 45s and 30s, we can get those exact radians off of, or our points off of our unit circle. So what is the point at sine 45 on our unit circle? Root 2 over 2. And what's cos 30? Root 3 over 2. Subtract what's cos 45? Root 2 over 2. And what's sine 30? Half? Okay, so now we're just down to points, and then we just have to multiply. So tops and tops, bottoms and bottoms. So root 3 times root 2 is root 6, and 2 times 2 is 4. And then we have subtract, root 2 times 1 is root 2, and 2 times 2 is 4. And you can't subtract roots that are the same. Like you can't go root 6 minus root 2 is root 4. You can't do that because they're different roots. So all you do is write root 6 minus root 2 all over 4 because 4 is a common bottom. And that would be our answer. Because roots have to be the same root in order to put them together. That's our final answer. Root 6 minus root 2 over 4. Okay, and then our last example, we have tan 105. So how can we make 105? 45 and 60. Okay, and so how does tan work in the sum identity dealio? Tan A plus B. Oh, just wait here. We can even do it different. You just said it's 60 and 45. So tan is the same thing as sine over cos, right? So you could say sine 60 plus 45 over cos 60 plus 45 is the same thing as tan 105 because those all add up to 105, right? And tan is the same thing as sine over cos. Okay, and then we can use the sine addition, no, what is it? Sine sum identity, and we can use the cos one. Okay, so the sine one goes, when you have the plus sign, it goes sine A. So A in our situation is 60. So go sine 60 cos 45 plus cos 60 sine 45. And then our bottom would be when we use the cos sum identity. And we're using the plus one, so it has a minus in between. So you're going cos 60 cos 45 minus sine 60 sine 45. Okay, so all I did was follow those identities and put 60 and 45 in them. Okay, now we just need to replace all of those with values from the unit circle. So sine 60 is root 3 over 2. Cos 45 is root 2 over 2. Cos 60 is 1/2. Sine 45 is root 2 over 2. And then we still have the bottom here. And cos 60 is 1/2. Cos 45 is root 2 over 2. Sine 60 is root 3 over 2. And sine 45 is root 2 over 2. And then all we have to do is simplify. So we're going root 3 times root 2 is root 6 over 4. What's that? We can't cross off because it's an addition and subtraction question. I think if there was no signs in between, it's all multiplication, then you're good. Okay, so 6 over 4, and this one is plus root 2 over 4. So I'm just going to combine our top here. Our top would be root 6 plus root 2 over 4. And then our bottom is going to be root 2, and we're going to have a common bottom of 4. Subtract root 6. Well, and that looks really ugly because it's that divided by that, and it's all fractions, right? So, just to make it look better, I can't make my page longer. To make it look a little bit better, we said we had this, and it was being divided by the bottom, right? So I would actually multiply by the reciprocal. And so these guys can cross off, and then we'd have root 6 plus root 2 minus root 2 minus root 6.